Alright guys, as promised, I'm going to go through a calculation using Excel for a problem on 11.2. So I'm looking at number 2 here with the M&Ms. So the way to do this, to use Excel, is first of all, we're going to create a table similar to the table we did in class. So I'm going to come into Excel and start out with my category. The one thing I'm doing different than what we did in class is that I'm adding this column for my proportions. So in these problems, like number 2, where I'm given the proportions, I can just type in the proportions of each category. So I had 0.13 red, 0.22 orange, etc. So I've got all that information in my Excel file. Now the rest of this is going to be exactly like what we did in class, except of course we're going to use Excel to do all the calculations for us. What we need for the observed values is, based on our sample, how many of them were red, how many of them were orange, etc. So we get that from this table. Now there's some extra information here. We don't need the weights, but that's what the table is giving us. But what we need is the number of reds. So in this case there were 15 reds. There were, scroll down to get the number of oranges, there were 24 oranges. There are 6 yellows, 7 browns, 27 blues, and looks like 21 greens. So ignore all the weights that are given in the columns. Just look at how many there were for this problem. Okay, so let's go put those into Excel. So we had 15 red, 24 orange, 6 yellow, 7 brown, 27 blue, and 21 green. Double check my numbers. 21 green. Okay. So on Excel, to calculate the expected frequency, that is, the first thing we need to do is count up how many observations there were total. So let me get the sum of all my observations. And there were 100. Now I believe this particular problem will always come out to be 100, but in general you want to count up the number of observed frequencies. So that tells you there were 100 M&Ms we observed. If reds were in proportion of 0.13, or rather 0.13 of our M&Ms should have been red, then we have to take our 100 M&Ms, multiply them by 0.13. So what I'm going to do to calculate that is equals 100 times, and then click on the column that's holding my proportion. You could do that one in your head because 100 times a decimal is easy to calculate. But again, if our observations were something different than 100, then Excel would do that calculation pretty quick for us. So I want this for each row, so I'm going to click on my lower right-hand box, drag it all the way down, and this gets me my proportion times 100. These are what we would expect to have happen if the proportion of red M&Ms was 0.13, of orange M&Ms was 0.22, etc. Good, so now we're going to get the O minus E column by typing in equals. Click on our observed column minus our expected column, and we'll again drag that down to get the subtraction of everything. Now we want O minus E squared, so I'm going to type equals my O minus E column, and then caret. You get that caret by Shift 6, and that tells you to raise the cell E2 to the second power. So drag this down, and finally take each of those in my O minus E squared column and divide that by the expected column, which in this case I've got 4 minus 13. I'm going to drag that down over the rest of them. So finally, what I need to do is add all those up to get my test statistic. So this is not a t statistic, this is a chi-square, so whatever you want to type in for that. My chi-square is going to be the sum of this column on the far right. So my test statistic is 13.964 rounded to 3 decimal places. So let me come back in here and type that in. 13.964. The critical value we're going to get from the chi-squared distribution table. But first we need to note that there are 6 categories, so our degrees of freedom are the number of categories minus 1. So we're going to be in the 5th row on our chi-squared distribution table. I've forgotten what the significance level is, so let me go back to the problem. We're going to use a 0.1 significance level. So in the 5th row, go over to the 0.1 significance level. Looks like we're going to have 9.236. 9.236. So in general, if your test statistic is greater than your critical value for one of these chi-square distribution problems, you're going to reject the null hypothesis. Now, think about what the claim is. The claim is that the color distribution is as claimed. So that means the proportion of each is exactly these, or equals these percentages. The null hypothesis is the one that has all the equals. So the null hypothesis comes from our claim. If we're rejecting the null hypothesis, then we can reject the claim. So there is sufficient evidence to warrant rejection of the claim. Oh, I guess I got to check my answer. All right, so that's all you have to do. Now, anytime you want to do any of these other problems, as long as you have the correct number of categories, so you might need to subtract some categories or add some categories, put in the right proportion, put in the observed frequencies, and then all the other columns will be calculated automatically, with the exception, I guess, of the expected. We'll have to change 100 to whatever the sum of our observed frequencies are. All right, good luck.